we're going to work on the free radical halogenation of alkanes. When you do this, there are several things you need to remember. I'm going to give you a very generic alkane to work with. The alkane that you are using, you want to always go for the position that would make the most stable radical. And we've talked about this in class already. The most stable radical is the one that can be stabilized very much like with the carbocation by induction and hyperconjugation. Now, unlike carbocations, there will be no shifts. So you don't have to worry about it moving from one place to another. And this tends to work best with bromine. Bromine is highly selective, much more so than the chlorine. Chlorine, you do have some selectivity, but it tends to really chlorinate any position, and it doesn't tend to stop at just one chlorination product. Bromination does tend to stop at one bromination, and it is highly selective. So when you're doing these types of reactions and trying to get a particular product, you'd want to do bromination. The first step in this mechanism is actually the initiation of the radical. And this occurs by breaking apart a completely homolytic bond. And this is because there is no preference in terms of electron negativity for the electrons to go to one atom or another. They're sharing them equally. And so when you do hit these molecules with the appropriate wavelength of light, which we're designating by Planck's constant and nu, this bond will break apart homolytically. So we use single-headed arrows to show single electron movements. And when you're done with this initiation step, you produce two bromine atoms, or you can call them two bromine radicals. Now, I tell stories with reactions, but a radical propagates a radical. It's like the Gadiant and Roberts. Okay, so once you have a radical, it's going to keep propagating a radical. That's why they call it propagation. If you start with a radical, you need to make a radical. Otherwise, you've done something very wrong. Okay, now this was the molecule I gave you in the beginning. So there are 3 primary carbons, 1 secondary carbon, and 1 tertiary carbon. The bromine is going to go and steal a hydrogen atom, and it wants to do it in such a way that the molecule doesn't notice that much. You want to make the most stable radical possible. So when doing this, you're going to take it from this tertiary position. And be aware, the bromine only wants 1 electron. So we're not taking a proton, which is H+. We're not taking a hydride, which is H-, that has 2 electrons. You're taking hydrogen atom, which is just the hydrogen and 1 electron, because bromine only needs 1 more electron to complete its octet. So make sure you're showing all of your arrows, because you have to show where every last one of them is going in this process. So in this process, you make a molecule of HBr, and this is always in the gas phase, and then you're going to make your alkane radical. Okay, and this one's tertiary. So a radical propagated a radical. That's the first step in the propagation. Now, this new radical that you've created is not happy either. This carbon only has 7 electrons around it. It needs an octet. Now, I see a number of students do a number of things that are bad. You don't want to go and get the other bromine radical and bring it in at this point, because that would be a termination. You would not be propagating a radical. So what you actually need to do is bring in another molecule of bromine. Make sure it's the molecule of bromine and not the bromine radical, because this is much more abundant in the solution. It's not very likely that you're going to come in contact with the bromine radical. It's possible, but it's not likely. But it's going to take one of these bromines because it just needs 1 more electron. And it's a propagation step. So you start with the radical, you've got to finish with the radical. So this is how we actually make the alkyl halide. And then you would also produce another bromine radical, or bromine atom, that can continue to go through these propagation steps. That's why they're called propagation. You just keep going. So this guy right here, this one, he can just keep doing this reaction over and over and over again with more alkane, but it has to be a different alkane. Okay, we're just showing one equivalent. Now, that's the important part of the mechanism. Some other things that can occur are termination steps. Now, this is the one I didn't want you doing in that last step. But one of the things that can potentially happen is that that alkyl radical could react with a bromine radical. And they can come together. And they might make this alkyl halide. It is possible, but this is not a propagation step. This is a termination step. And it isn't very likely, again, because it's not very likely that the two radicals are going to find each other. But it is a possible step. Another thing that you could do to show a termination is show two bromine radicals coming together. And again, I'm using these single-headed arrows to do that. And that makes some bromine molecule. It doesn't really matter what you're bringing together in the termination step, as long as they're both radicals and you do not propagate a radical.